This first video, we are going to cover units from chapter 0. Now, in chemistry, numbers are meaningless if they don't have a unit after them. For example, think about just saying the number 1. Without a unit, this number 1 could mean 1 mile, 1 meter, 1 liter, 1 second, or anything. So it's very important to specify a unit. And for instance, if we have 1 mile versus 1 meter, this number 1 will have different values because it has, or different meanings because it has different units. And so what a unit is some defined physical quantity. In chemistry, we will be using what are called SI units, where SI comes from the French phrase for International System of Units. Now, there are 7 fundamental SI units, and the ones that are going to be most important for us in Chemistry 121 are the units for mass, length, temperature, amount of substance, and time. And so I'd like to also say that these are some what are called fundamental SI units. In a couple minutes here we'll also get into what are called derived units. So for mass will be measured in a kilogram, and a kilogram has the abbreviation lowercase k, lowercase g. Length is measured in a meter, and its abbreviation is lowercase m. Temperature is measured in Kelvin, which is shown as capital K. Amount of substance is called a mole, abbreviated as MOL. And the fundamental SI unit for time is the second, which is shown as the letter S, lowercase letter S. So these are the fundamental SI units we will be using in this course. There are also things called derived units. And what derived units are some mathematical combination of fundamental units that represent different physical quantities. For instance, area is two-dimensional length, so it's length squared. The fundamental SI unit for area is meters squared, so you take whatever fundamental SI unit needed for length and you square that to get area. We'll do the same thing for volume. Volume is three-dimensional length, so it would be length cubed. So for the fundamental SI unit, it would be meters cubed. Meters cubed is not an easy volume to work with. Something that's more common would be called a liter, and a liter is a common unit of volume. However, it equals a decimeter cubed. And the final example I'll give for derived units is density. Density is a measure of something's mass divided by its volume. So we take the fundamental SI unit for mass, which is the kilogram, divided by the fundamental SI unit for volume, which would be meters cubed, and you get kilograms over meters cubed, you'll find that in this course we'll often measure density as grams over milliliter or even grams over centimeter cubed. So we may use other units, but the ones I'm showing you are the fundamental SI units. Making measurements, you might find that the fundamental SI unit that we just talked about might be either too big or too small for the measurement you're working with. In this case, it's appropriate to use a metric prefix to change the magnitude of the SI unit. A metric prefix is some factor that is multiplied by what's called the base unit to change how big that base unit is. When I say base unit, this is one of the fundamental SI units given a magnitude of 1. And all fundamental SI units except the kilogram is also a base unit. So the kilogram is actually 1,000 grams, and the base unit with a magnitude of 1 would be the gram. So examples of base units are the gram, the meter, the liter, etc. So these are units that do not have a prefix in front of them. Now, how metric prefixes work is you take your base unit. I'll just be using a gram as an example in our case, and you multiply it by some factor of 10, and that will change its amount. When using a metric prefix, you put some prefix in front of the base unit to show the new magnitude of the unit. So you can have base units that make you can have metric prefixes that make your base unit smaller than 1, and you can have metric prefixes that make your base unit greater than 1. For example, smaller than 1 metric prefixes would be like deci. So deci is the name of the prefix. What it means is you multiply your base unit by a factor of 10 to the negative 1, or 0.1, to get a decigram. And a decigram would be abbreviated as lowercase d and then gram. But remember, you can use any one of these base units with this metric prefix, or any metric prefix. So you can have deci, a factor of 1/10. You could have centi, in which you multiply your base unit by a factor of 10 to the negative 2, or 1/100th. It's abbreviated as lowercase c, so you could have a centigram. And you can also have milli, which is a factor of 10 to the negative 3, or 1/1000th. Now there are several more, but these are the most important ones for our course. As far as base units that can be greater than 1, the first one would be deca. This guy is D-E-K-A, where deca is multiplying your base unit by 10 to the 1, or just 10, and its abbreviation is DA. So a decagram would be called DAG. You can have hecto, which is multiplying your base unit by a factor of 10 squared, or 100, and this is abbreviated as H. Just lowercase h, and then for a hectogram you would say HG. You can have kilo, which is multiplying your base unit by a factor of 10 to the third power, or 1,000. And so a kilogram, which is the fundamental SI unit, a kilogram is lowercase k, lowercase g. We can have mega, where mega is multiplying by a factor of 1 million, or 10 to the 6th power. And for megagram, you need to use a capital M and a lowercase g. And one more example, giga, so I'm going to write it over here because I can't fit it here. So giga is multiplying your base unit by a factor of 1 billion, or 10 to the 9th. And so if you wanted to say a gigagram, you would use capital G and then lowercase g, where capital G represents giga. So remember, I just used gram as an example in all of these abbreviations here. However, you can put any base unit in there with a metric prefix to get a new magnitude for that metric prefix.